All right, I guess we can get started. So in this session, we are now live on Zoom and Facebook, YouTube, and LinkedIn should be as well. So wherever you're watching from, on or whichever platform, welcome. So thank you all for coming. Some people are, probably still joining in here. But yeah, we haven't done something like this in quite a while. And I figured, yeah, it just makes sense to do, this sort of workshop on UgCS, just to, in general, tell DJI, drone owners and pilots, so what can UgCS, how can UgCS help you? What can you do to get more out of your DJI drone? And also, of course, we'll cover some other related questions, essentially anything about drones. So let's get started. Mostly, actually, this session will be about practical aspects. So my presentation it will be quite short, but yeah, most of the time we'll spend actually working with the software. So for those of you who are quite new to UgCS, just I recommend if you can. You can also have UgCS installed on your computer. You can follow along and try to, learn more. So hopefully this session will be quite useful for you. So let's get started. Some general info at the very beginning. So I think that the approximate duration of this will be around 1 hour with the QA session. Could be a bit longer. So if we go above the 1 hour mark, yeah, anyways, the recording will be available afterwards. So in case you can't stay until the end, then you can just find it later on our YouTube channel, UgCS TV. For those of you who are watching on Zoom, please make sure to put all of your questions in the Q&A section of Zoom. And yeah, if you're watching on live stream, just put everything in the live stream comments, and then also I'll be answering questions from here and there. Please, if you have any questions on Zoom, do not put them in the chat. Put them in the separate Q&A section. That will be way easier for me. Otherwise, scrolling through the whole chat might be a bit too much for me. So yeah, this webinar, like I said, is recorded. Recording will be sent afterwards and published. So yeah, initially a bit about the agenda. So we'll have a short intro. And that's what I guess I'm doing already now. Then we'll talk about getting started with your DJI drone and UgCS. So different ways how you can use them, how you can connect, and so on. We'll get into the flight planning itself, of course. I'll try to kind of guide, I'll try to make it interesting for both people who are new to UgCS and also more experienced pilots who might want to discover something new. And yeah, we can just talk in general about how you can maximize your drone's potential with UgCS. And if some question, I'll try to answer some of the questions live in the session. But just in case your question doesn't get answered, don't worry, we will do a Q&A at the end. So yeah, I'll try to answer as many of your questions as there will be. So yep, I think at the very beginning, actually, what I would like to do, I would like to do a quick poll, because one thing I'm interested in is seeing, so what are your different backgrounds in terms of how do you guys use drones? So if I will be able to figure out how to do this here through Zoom. Okay. So I think the poll will be only for those who are now on Zoom. So if you're on other streaming platforms, then please hold for just a second. So yeah, I just launched the poll, so you should be able to now see it and answer. So basically the question is just about, so for what application do you primarily use drones? And yeah, so here the options are search and rescue, solar panel inspections, power line inspections, doing also power line corridors with LiDAR, inspecting wind turbines, inspecting sites, including 3D model creation, and so on. So yeah, just let's take a few minutes. Please answer this, and then after that we can go on and already get started. And actually, so while you guys are answering, I will probably already switch my screen. So I'll stop the screen sharing for just a moment, and then let's switch into something else. So I'll now just go ahead and share the screen again. And so here, yeah, a poll is still active. So please, I'd appreciate if you all could vote, at least those on Zoom. And while you are still doing that, I can already start talking a bit about, like I said, the intro part of UgCS. So as far as what different DJI drones we support, I think that probably makes sense that we cover it first. So on our site, so if you just enter gcs.com, also actually if you scroll down here, you will be able to see well, all different drone platforms we support. But in general, so the most popular ones are these larger DJI enterprise drones. So this is your DJI M350, M300. So actually, I'd say quite a significant amount of our users are using specifically these platforms. Alongside with these, also we support the DJI M30 and Mavic 3 Enterprise drones, as well as, of course, all the DJI drones such as the M200, Phantom 4 series, M600, Mavic 2, and many, many others. Actually, when UgCS was made initially back in 2013, 2014, it was made as this universal software with the intention that it covers different drone platforms. And we've stayed true to that, I'd say. So even if you have some other drone, or maybe you might have some drone made by DJI, and since I saw this one question related to this, that there's, for instance, if you are flying USA governmental projects, then you might not even be able to use DJI. So in that case, also we support other drones. So drones based on Autopilot and PX4 platforms. So these include free fly drones, Inspired Flight, Harris Aerial, ACECore, Aurelia, and others. So UgCS is still universal. So actually most drones on the market can be used with UgCS, and this includes actually also fixed wing and VTOL drones. So yeah, that's initially about that. One question we actually get quite often that's related to DJI drones is how can you control different types of DJI drones? So what is the way how these can be connected to UgCS? So I'll just kind of want to get this out of the way first. I just cover it, and then we can go into the software itself. So up until, I'd say, up until the beginning of last year, in general, there was only one way how you could use DJI drones with UgCS. And that was using our mobile app, UgCS for DJI. So if on our site, you go up here under downloads and then go to UgCS. So then I'll just check. Yeah, screen sharing is working. So in here, you can see we have, of course, the download for UgCS itself. So for Windows and Mac platforms. And also we have UgCS for DJI. So most drones, at least most older DJI drones, were using this mobile app. So the idea was that you install this app either on your Android device or DJI smart controller. In the case of DJI M300 drone, connect the computer and the Android device or controller on the same network, and then the drone appears in UgCS. But now actually there's 3 different ways how you can use UgCS with your DJI drone, depending on which drone you have. So with the older ones, up to and including the M300, you would still use UgCS for DJI app. For newer drones, DJI enterprise level drones, so these are your M350, Mavic 3 enterprise series, also including thermal and multispectral, and M30, and also, of course, M30T and M300. So M300 kind of goes both ways. So with these newer drones, you can use DJI Pilot 2. So you can connect DJI Pilot 2 directly to UgCS. So you will see drone telemetry. You will see all routes you have planned for your drone in UgCS. You will see them inside of DJI Pilot 2. Yeah, so that's basically how you can plan your missions in UgCS very, very easily, then save them locally on your DJI Pilot 2 and fly. So that's way number 2. And actually now there's a third way how you can sort of have this desktop flight planning capability for your drone. is that now we have a new app. So if you go here into the SkyHub section, now we have this app called Sky App. Actually, this is currently at least the public version. This is only for users with M350s. But this is for now intended as a lightweight version of our previous app, which allows you to connect also that drone directly to UgCS. If you have Mavic 3 Enterprise or M30, you won't be able to connect with the public version yet, but also we will soon have an updated version where you will also be able to connect and you will be able to see the video feed from these drones as well. So we are still working on adding some new features. For now, it's just a lightweight version, but more features are coming, is what I'm saying. And also, by the way, the app will be rebranded. So now you can see the name Sky App, but we realized it might be a bit too confusing since we have the SkyHub device, which you can put on the drone to get through Terra Following. That's why we realized, okay, we'll rename this app. So the new name of the app will be UgCS Companion. So in case you'll see this in the future, just know Sky App will be renamed to UgCS Companion. So yeah, that's just one little detail. So yeah, in any case, 3 different ways how you can connect your DJI drone to UgCS. But yep, now I think maybe let's get into UgCS itself. So let me again, I'll stop the screen share for a moment and let's jump into the software. I will, by the way, from time to time, maybe do a bit of a pause and go into answering some questions. So if you have posted your question and I just haven't answered it yet, then just please be patient with me, and I'll try to get to it. So I think now the poll is done. So I think then I see about 80% of you answered. Actually, I'll leave it out for just a bit more in case those 20 remaining percent of you here on Zoom platform, if you could answer it, that would be super. But yeah, then let's get into the software. I'll share my screen with you, and then we can get started. So this is UgCS version 4.20. So this is currently the public version we have on our site. And as at least those of you who are also on our Facebook group and elsewhere, if you might have noticed, actually we have something quite cool in the works. So we are very close to releasing a new major version of UgCS 5.0. And in version 5.0, we will have an updated user interface. So it will be more easier to plan your missions. It will be more modern, user-friendly. Some other important and cool things include that it will be now, for instance, now the parameters will be split into the basic, then advanced parameters and actions. So hopefully we'll also speed up the flight planning process a bit, and various other cool features which you'll have. So, but yeah, for today I chose, let's not show it yet. Let's see, maybe if I feel like at the end I might show a bit, but I'm not promising that. But so for now, 4.0, 4.21. And the 5.0 version is scheduled to release hopefully next month, if all goes to plan. So yeah, in case you're wondering, it's coming soon. So yeah, we'll keep you posted. Make sure to follow all our social media channels. And yeah, anyways, let's get started with 4.20 version. If you have it installed, you can also follow along, and then we can cover various things, which yeah, is the reason why people choose to plan their flights in UgCS. So now actually let's zoom out a bit from here, and let's maybe start by just a bit of an introduction, since I know some of you are still very new users to UgCS. So I just want to kind of introduce you to the flight planning aspects, where is what, and then we'll get into a bit more advanced stuff. So the interface itself split into 2 parts. Everything here on the right side, this is concerning your drones. So here you have all the drones. In this case, I have my emulator drones in here. If you have your DJI drone connected, either through UgCS or DJI app or the Sky app, or also through DJI Pilot 2, you will see this drone appear over here, and you can have multiple of them also connected simultaneously. To connect also from Pilot 2, you can go here, and then this is the address you need to input into the Pilot 2 app. So on this side, you see the telemetry window as well as different commands you can send to the drone. And then everything which is on the left side of the screen, this is concerning your route planning. So the idea here is that we have a mission, as you can see here, and then for any mission, we can have multiple different routes within the mission. And this actually allows you to do route export and mission export as well, which means that if you export your whole mission, then all of the routes within it will also be exported. But yeah, so then let's get started with some flight planning. So now we have, let's actually remove these points. So now the most simple flight planning tool is just using the waypoint. So with the waypoint tool selected, we can just go ahead and place them on the map like so. So that's the most simple segment, of course. And then in here also you can see different parameters you can change, as well as actions which you can add. But then going into other things UgCS can do, it actually includes planning more complex routes, because actually that's the one of the main reasons why drone pilots choose to use UgCS rather than the app which comes with their drones by default, is that you can do these more complicated tasks. You can get those better paying projects. So one of the most common applications, of course, is photogrammetry. So now we can get into this as well. So actually, as you can see, this route I have planned for the DJI Mavic 3 Enterprise. So this is just a simple waypoint route. And actually, let's do the following. Let's just create route number 2 from scratch. Let's again select the DJI Mavic 3 Enterprise drone, and then let's select our photogrammetry tool. As the camera, of course, let's choose the wide camera and ground resolution. Initially, let's maybe select just 2. So then we can mark out some area which we want the drone to cover. So let's, for example, select this one over here, and then also let's adjust our direction angle. Let's wait for the route to be calculated, and there we go. So this is just a very simple example. And now let's get into a bit more detail on what kind of things you can fine tune. One of the first ones actually is that you can have within your route not one segment, but multiple segments. So in this case, you can see we just have a photogrammetry mission. But actually, if you want to, for instance, add certain waypoints before that, for instance, one reason why I would do that is, let's say if you're located somewhere over here, you might want to start the route from the closest corner of the photogrammetry. And so to do that, you can click here on add first waypoint, and then we can add it, and you can see, so it kind of, snaps to the closest corner. So to whichever corner it snaps, that's where typically the flight will start from. It's not mandatory to add these extra waypoints, but that's just something you can do if you want to. Moreover, if you, for instance, want to cover not just one area, but multiple areas, then you actually can have simply multiple photogrammetry areas or any other segments within a single route. So for instance, if I wanted to cover that area and then maybe fly over here and cover this one as well in the same flight, then I can do it like so. So again, just placing 4 points. Of course, if you want, you can adjust and add more approximating points for the photogrammetry area. Yeah, so that's now already two photogrammetry areas in a single route. Let's then also maybe go and check out what other parameters we can change here. So flight speed currently is set to 5 meters per second. The turn type, if you want, you can change. Here we have the stop and turn. If you want, you can also use the adaptive bank turn. So let's just use adaptive bank turn. Ground resolution currently set to 2 centimeters. And if we zoom in, we can also see here in the tooltip, so what's the current AGL altitude, at least of this point. And what I usually do is also, if you go here into parameters and then show elevation, then you can get this elevation window, which you can also, make smaller, make larger, however you want. And so here also you will see the total estimated duration of this flight. In each of the route segments, you can also add different actions. So in this case, you can, for example, see that we have this set camera by distance action. You can either use this, or alternatively, you can also use set camera by time. So then here, automatically UgCS calculates how often should the images be taken. And also what I typically do is I add an action to set the camera to a certain angle. In this case, since we have a first waypoint here at the very beginning, I will add this action here. So simply set camera attitude and then set it to have a tilt of 90 degrees. So now already, basically when the drone takes off, camera will be set 90 degrees downwards and will fly throughout this photogrammetry, taking images. So this is just how you do very simple mapping. Of course, this flight is also done with terrain following. So by default, we have the smart AGL terrain following mode. So this is actually the more kind of advanced terrain following mode, which allows the drone to follow up even if it's flying up a near vertical surface. So I know actually some years ago, we were one of the, well, basically a lot of pilots were choosing UgCS because of our terrain following. And now, of course, even though many other solutions have terrain following as well, I would say that we're still a bit ahead in the game. At least that's what I personally consider. Because what we do is also that if you're using the smart AGL terrain following type, this means that the drone, it doesn't only take the distance right below where it is, but it calculates the distance also to the nearest terrain surface, as it's at least towards the direction of the flight. So this means that even if it's flying up near vertical surface, it will keep a constant distance of those, let's say, 50 meters towards the surface. So that's something interesting, which actually allows you to fly in these types of areas where the terrain might be changing very rapidly, and you can still gather high quality data. And this gives you more assurance that the drone will not simply crash into a wall just because the points are only placed beneath it. Because otherwise you might run into the problem where, let's say, if you have a very steep terrain, then the waypoint might be placed very close to the cliff itself. So that's about that. So very simple photogrammetry mission. What I also typically do is, in case you want to, for instance, create a 3D model out of this, then you can change the overlap settings. So here we have 1630, and then of course you would probably be using something like 80 and 80% overlap. So that's for planning photogrammetry missions. One other thing I want to show you, and I will probably also get to this a bit later, but if you want to create what's now popular is digital twins using drones, then there's a few additional things you might want to do. So let's say in this case, we have this photogrammetry mission with 80-80 overlap, and then we might want to do not only those nadir images, but we also might want to do images at 45 degrees. So how do you do that, and how do you capture from different angles those types of images? So let's do the following. I'll just remove this third photogrammetry segment. And now actually let's just add a new route for this. Let's make it route number 3. And so now what we can do is we can, again, choose the photogrammetry tool. But in this case, we can select a larger area in here. And now in this larger area, we can also check the double grid option. So if you have this double grid option checked, this will mean that the drone will be taking, well, it will basically be a double grid of the photogrammetry flight. So let's select that here. Well, we can keep smart AGL, or also you just use normal AGL, but well, and I think I'll keep smart one. And another difference which you need to take into account here is that the camera you now will need to set at 45 degrees. So now we can actually add this set camera attitude action and then set it to tilt 45. This is actually quite a large area, so it might take a bit for it to calculate. But yeah, in the meantime, I can say that there's in general actually 2 ways how you can create well, these types of images for creation of digital twins. Number 1 is that you can just fly at 45-degree angle. That's actually also what DJI Pilot 2 does, but in that case, it creates 5 separate routes for you. But in this case, with GCS, you can do it with just one route. Of course, this is quite a large area, so now it does look like this. But anyways, one option is doing with 45 degrees. But when you, for instance, need to create a model of some building or bridge, then another option, which I have done in the past, is that instead of just doing 45, you can do 60 and 30 degrees. So idea would be that you fly from one altitude where you just capture those nadir images at 90 degrees, and then you kind of go a bit downwards. So then at slightly lower altitude, you capture images at 60 degrees, and then you capture them at 30 degrees. So by having those 3 different angles, you're able to create a more accurate model than you can create with just 90 and 45. So that's just a bit of a, also, I guess, suggestion which you can try to do if you want to do those types of flights. So yeah, that's regarding photogrammetry. Now, also, I think one of the next things is we can cover doing some corridor missions, because actually corridor flights, especially those above power lines with LiDAR, it's quite a popular application among our users. What's cool is that you can use actually GCS with not just DJI LiDARs, but also LiDARs made by, for instance, Yellowscan, Rock Robotic, Phoenix LiDAR, and many, many others. So essentially any LiDAR which can be mounted on a drone can also be used with GCS. So now let's maybe go into some LiDAR flight planning. For that, I will create a new mission here. So in this case, let's maybe select the M300, or maybe even let's do the M350 drone. Actually, in the meantime, let's see if there's any questions I can answer. So yeah, session is being recorded, so don't worry about that. About version 5, yes, when it comes out, it will be supported on Windows 11 and Windows 10. And even version 4.20, it's also actually supported on both Windows 11 and Windows 10. I'm now running version 4.20 on Windows 11. Okay, there's actually quite a lot of other versions, so these I'll try to answer in just a bit, otherwise we'll get a bit distracted. So I think in the Q&A, I'll try to go through as many as I can and then answer. Just very quickly, yeah. So there's a question about data processing. So about the technique of if you need to capture images from different degrees, so how do you actually stitch them together? I have used personally 2 softwares in the past. I've used Agisoft, Metashape for that, and also Reality Capture. Out of both, at least personally, I prefer the Reality Capture a bit more, but I think Agisoft is also a really great software. So yeah, there's also Pix4D and others which you can use for that purpose. So you're not really limited, but yeah, at least that's what I personally liked. So yeah, let's maybe go a bit into the corridor flight plans. And again, don't worry, in case your question didn't get answered yet, we have a bit of limited time, so I'll try to cover as much of the flight planning as I can, and then we'll just jump into all of the questions you guys have. So now let's go into the corridor missions. So for corridor, actually, we have in general 2 types of corridor missions you can plan. One is the normal corridor mapping. So this is actually similar to how photogrammetry in UgCS works. So you set a certain ground resolution distance. So in this case, it's 1.4 centimeters. You choose which camera you want to use, and then UgCS kind of just does the rest. So that's for the mapping corridor, but I think now maybe let's go a bit into LiDAR corridor and how is this different. So with the LiDAR corridor, you specify the flight height explicitly. So if you say you want to fly at 50 meters, then that's what you can enter here. And by the way, for those of you from United States, I know many of you prefer to use the Imperial system. So if in case you want to use Imperial, you can actually switch UgCS to Imperial system. So you can go here in the main menu, then configuration, and then measurement. And so then here, if you want to, you can switch from metric to Imperial system for your flight planning. But so let's plan a quick LiDAR corridor. So let's just, with LiDAR corridor tool selected, we can just place a few points like so. By the way, what's interesting is that if you want to plan your LiDAR corridor, not just by placing points, but if you have maybe some KML or CSV file of some targets which you want to scan. So these could be, for instance, some power line tower locations and so on. So you can actually automate the creation of routes. So when you click here on add new route, there's this option import from file. So actually, if you choose that and then you choose some KML file or CSV file, then the route will be created automatically. With KML, you can choose how you want linear segments to be imported. I'll actually maybe see if I can show you some example. Yeah, so with KML here, you can see how linear segments are imported. So either as waypoints, corridor, vertical scan, or LiDAR corridor, and polygons are imported as area scan, photogrammetry, perimeter, or LiDAR area. With CSV, actually, you can also automate what actions are added. So that's also one, I suppose, interesting thing, which you can automate with that. So, okay, here we have a corridor. I got a bit of an error about the fence radius. So in case you plan your flight a bit too far, then you'll get that. And then don't worry, just click here on change fence radius. We can just enter some slightly larger value in here. Click on OK, and then it should calculate our corridor mission. So for the corridor, of course, now I just place those points kind of randomly, but if you want, you can grab any of these middle points of the lines and you can move them around so you can actually adjust the corridor exactly to your needs. So one way is planning it manually. Another way is importing it from a file, like I just explained. And actually, there's another way what you can do is that you can add a 2D object into UgCS, and then you can plan using that 2D object. So I'll cover that in a second. So for now, I'll just a bit show how you can do this. But I think here you kind of get the general idea of how you can do these kind of fine-tuned adjustments. So then let's go a bit through the settings of what you can change in your corridor missions. So one of the main ones actually is the width of the corridor. So here you can see that our current width is set at 30 meters, which at this 50-meter height just means we have one line in going in one direction. And so in case you want the corridor to have kind of these two lines next to each other, then you can just increase this width parameter. So for instance, if we now set this to 90 meters, let's see if we get two lines in here. Yeah, and yeah, no, actually we get three. So we can go a bit down. Let's go down to maybe 80. And let's see. Yeah, so with 80-meter width, you get those two lines for the corridor. Also, we can go here and again, click on show elevation to preview the elevation profile of this corridor flight. So you can see here total estimated distance, estimated duration, as well as the number of waypoints. Oh yeah, actually, one really great question, which I think I'll answer in a bit, is about importing a custom DEM. And the answer is absolutely. You can import your own DEM. That's actually what I'll show you one which I imported today when I had to construct a flight for one customer. Actually, this will be interesting because this was a flight where we did a vertical scan. So I think let's cover the LiDAR corridor, and then we will go on to DEM file import and how you can do that, because that's a thing which actually I think most of you will probably have to use. So then in the corridor flight, what else you typically add if you are using, for instance, DJI L1 LiDAR. So let's maybe go ahead and select that here. Then if you want to have a colorized point cloud, then also what you can do is you can set, for instance, this same set camera by time or set camera by distance. And then also this, of course, will capture not only the LiDAR point cloud, but also the images from the LiDAR. Some other things, again, altitude mode, you can use either smart AGL or normal AGL mode. Flight height 15 meters, if you want, you can change that. We also have this line spacing, so you can either use the overlap way, or if you want to specify the line spacing yourself, then you can also actually specify the side distance here. So you can choose sort of which one to use. Flight speed also by default is 5 meters, and you can set it to more, of course. And also you can set things such as forward overlap and so on. For LiDAR missions, also what is cool is that we have the automated IMU calibration. So I'll cover two ways of how you can do that. Number one is if you're using a DJI LiDAR, so DJI L1 or L2. In that case, there is this checkbox. It says IMU calibration. If you check that, then you will see these IMU calibration parts of the root appear. So these are in this blue color, which you can see here under the mouse. And so what it does is it does the same exact thing which DJI Pilot 2 does. So the drone stops, then flies forward, backward, and then continues on the route. And so these segments are inserted exactly as specified by the manufacturer. So either every 100 seconds or every 1,000 meters, whichever comes first. In case, I know there's some of you who like to adjust these parameters, these can be adjusted in a configuration file we have. So if you want to, you can get in touch with us and we can also explain how you can do that if you want. But I think now let's maybe go a bit into how you can use UgCS with non-DJI LiDAR. Since I know that many of you who fly these more complex projects, actually, in many cases, I know pilots use other LiDARs. So for instance, the same rock robotic LiDAR many of you use. So how you can use custom LiDARs and cameras with the UgCS. If you go here under camera, you'll only see the default DJI cameras. So if you want to use some custom camera or camera which is not in the drone's profile by default, what you can do, you can go here into the main menu. And so now, pretty simple sections. In vehicles, we have all drones you have currently connected or have had connected at some point. Under profiles, these are all the drone profiles you have. So for example, if we go and find the DJI M350 profile, this is here. We can click on it. You can see all the parameters this profile has, such as the, let's say, defense radius, battery levels, and so on, along with what payloads are available for this profile. But there's also the payload section in here where we have a bunch of different cameras. And so, for instance, if you want to use some specific camera with your drone, then you can add it to the drone if the camera is here in this list. If it's not in the list, then actually you can make that camera's profile. So if you want to create a new camera, for example, you can click here on Create New, enter some name for it, all the parameters such as weight, true focal length, sensor width and height, as well as sensor resolution. You enter this, and then you will be able to add that to the profile. For example, so here I won't create a new one, but I will just add to the M350 profile one of the existing camera profiles. So we can go here on Edit, then click on Add, and then let's say I have a LiDAR with a Sony camera. So for example, if I have the Sony A6000 camera, then I can select it over here, and then you can see that this Sony camera has now been added to the M350 drone profile. So I can hit Save in here, go back, and then here in this route, I now should be able to find it. And there it is. So I can now select the Sony camera. And so this means that now all the image overlaps, all the front and side overlaps will be calculated using this camera. And so the same works not just for LiDAR, but also for photogrammetry. So even if you're using some custom camera or some camera which is not in the drone's profile by default, that's how you can add it. And if you have a question about LiDAR payloads and LiDAR, so how do you deal with that? Then the answer is simply that all you need for LiDAR is the field of view angle, actually. And that's enough to understand. So what should be the distance between the sidelines? So when you're using DJI LiDAR, UgCS, it actually includes the action to start and stop the LiDAR data recording. So both for the LiDAR corridor and for the LiDAR area scan, this action actually is added in there automatically. So it is, here you can't see it because it's already there. But if we, for instance, add a new point in here, then you can see, so there's a separate action actually available to set LiDAR recording on or off. But it's added automatically, like I said, to the LiDAR area and corridor. Some other things you can do. So if you want to, for instance, split LiDAR corridor or any corridor mission for that matter, let's actually I'll just go ahead and I'll remove the IMU calibration thing. Then, oh, sorry, speaking of IMU calibration, one thing I forgot to mention is, so I showed you how you can use the IMU calibration for DJI LiDAR. But in case you're using some other LiDAR, such as, let's say, Yellow Scan or Rock Robotic, then what you can do is you can add this automatic calibration pattern in here. So I just select this tool, then shift click and add the LiDAR pattern here to the map. I'll just need to adjust the length and width of it. But and yeah, I'll place it before the LiDAR corridor, and also then I can add it after that as well, if you also want to do another calibration after the corridor. So let's just select this, then the pattern, add it in here. So now, for instance, you can see the drone will do one figure eight calibration before the LiDAR corridor, then flies the corridor, and then does another one after it. There's different ways how people do these missions. Some like to do two lines, some just, it's okay to capture only one line if you have enough returns from the LiDAR. And also, actually, in some cases, I know some pilots want to have those sort of branches going out from the corridor. And I think also might be interesting for you if I show that. Actually, I think we'll probably for sure be above the 1 hour mark. So yeah, apologies for that, but we have a lot of ground to cover, and I see there's a ton of questions. But let's hope this is interesting. So if you want to split the corridor at any point, what you can do is you can go to any of these approximating points of the corridor, and then you can just right click on that and you can select split. And so what this does is that now it splits this corridor into two halves. So now you can actually see we have now two separate routes. That's just one of the things which you can do. Let's just undo it. And then another thing I want to show under, I guess, topic which you would call manipulations with routes you can do in UgCS. Is that if you want, you can convert any route into waypoints, and that also allows you to do a bunch of cool stuff. So for example, if you go here into parameters and then go to convert to waypoints, then now you can see we have a separate route, which is now fully, well, which is now only waypoints. And so for instance, now we can select this waypoint, which is here. Of course, if you want, you can even select multiple waypoints using shift click. But anyways, with this one selected, we can then again go into LiDAR corridor, and then we can kind of click away and add, let's say, one corridor here. If we want, we can go further. And again, I can select at this point and then add, for instance, another LiDAR corridor, which maybe goes in this here direction. So yeah, these are just some of the cool things which you can do. So essentially, any type of route which you want to create with UgCS, it is possible and it can be made. So any kind of custom solution, this is a tool which allows you to do all of that. But okay, I think enough time about LiDAR corridors. We will return to them in the Q&A session. So now I want to cover a bit about vertical inspections with UgCS, and also I want to show you how you can import custom digital elevation models. So one part of the software I didn't show you yet is the map options window. Those of you who are experienced with UgCS, I'm sure that you already know that. But so if you go here into map options and map layers, so then you can see this window. So here now we have, in this case, the map section where you can see the base map. So currently by default, we have Google Satellite as the base map. And then also, if you want, you can, for instance, change the base map. So you can change it to Bing, for example. Well, in different areas, different base maps might be better or worse. So sometimes it's just good to check and compare. And also there are overlay layers. So for example, here, if we now click on focus, we already have one overlay imported. And this is actually our flight area near our office. And I'll show you how you can do this, but it's very easy. So you can basically just click here on add, then enter some name for your map overlay. then hit upload, and then just choose the file. So in my case, this is, I think, yeah, this is the file which I imported. It's a geotiff file, so with the .tif extension. And these files can be imported as both, as map overlays and as elevation, actually. We'll get to elevation in a second, but yeah, so basically here, if you really, really zoom in, you can see, for instance, the difference in the amount of detail if you compare the default base map with the overlay. For instance, if we go here and see how the cars look like, and then we, for instance, take this overlay away, you can see how everything changes here and how much better it gets once we have the overlay. So where is this used actually? So users which typically use it are, for instance, guys who work in the mining sector, because in mining quarries, very often, of course, the map changes and the satellite map might be quite outdated and not as detailed, since especially equipment gets moved around often and so on. In the construction zones also can be very useful. So since there also everything's changing very often, then you might want to plan according to a more up-to-date map. And so this map, you can either import a map which you have created yourself with UgCS Mapper or with some other data processing software. Yeah, so then this just allows you to plan with more accurate data. But then going into elevation, so this is where stuff gets even more interesting, I'd say. So by default, we're using the SRTM 1 arc-second global data. So let's zoom out a bit. So here you can see everything colored in green. This is SRTM 1 arc-second data, and everything north of 60 degrees latitude. So this is a separate data layer. So we have data for both. But if you want to use your own digital elevation model data, you can also do that. So in this case, for instance, you can see today I had to construct a route from one customer of ours in New York. And so then I had to import this elevation layer in here. And might be actually interesting if I maybe show how you can do that, because maybe some of you don't know. And I think this is actually a topic I've never covered in webinars. So let's maybe quickly do that. So I'll stop the screen share for just a second, and I'll pull up the web browser, which is not this one. Let's do this. And then let's go into share, and then I'll show you again my screen. So this is here the United States Geospatial Service. There's a high degree of how to say, a high degree of similarity between UgCS and USGS. So yeah, just don't mix them up. But in any case, you can use both of them together. And so this service is actually really great for when you need to have some accurate elevation data, because so we have 1 arc-second elevation data. But from here, actually, you can get even more accurate. So you can get, for instance, a 1/3 arc-second data, which is 10-meter distance elevation layer. So for example, we can go, let's actually also maybe take as an example, where could we go? Let's see some interesting area. Okay, actually it doesn't matter that much. We can choose whichever. Let's maybe go to somewhere where there's a bit more mountains. So for instance, somewhere over here. So you might have some project in this area, but you might want to have more accurate terrain elevation data. So what do you do? So you can start by marking out a polygon of the area where you want to fly. So for instance, we can select a polygon here, hit enter. And then if we, for example, want to have the elevation, you can select here elevation products. And then, well, I just typically select all of these. And then as the file format, select geotiff. And now, next, basically, we can click here on search products. So now it does its search. And you can see here we have this tile. And so this is actually 1 arc-second data. But so in some regions, you have even more accurate ones. For example, in New York City, I could get 1/3 arc-second. So it will probably depend on where exactly you are. So for instance, let's go here. And yeah, let's also then maybe select some other area. just so we can see. So for example, here, we can go back here, data sets, then again, go to, let's actually go clear geometry. Then again, we can select polygon, select, let's say, this area over here. And then again, we can do search products. So in this case, actually, you can see we have this one arcsecond data. So let me zoom out a bit so you can see the full tile. And also we have this 1/3 arcsecond data. So 1/3, of course, will be more accurate. So if you want to download it, you can just go here to download a link, select that, and then this file will be downloaded to your computer, and then you can upload it into UgCS. So now let's go back into UgCS, and then I'll show you how you can upload it. Okay, so now you should be able to see UgCS screen again. Since it might take some time for that file to download, I'll just show you the general process, but it's very, very simple, exactly the same as I just now did for the map overlay. So you just, again, enter some name for your elevation source. Okay, let's not be lazy. Let's just do elevation. And then we can click on upload, and then we just select the exact elevation file. So in the case of New York, this was the file which I selected. So when you download it from USGS, it will also have in the name USGS, and then have the exact identifier for that map tile. And again, you notice it ends with this .tif. So then just hit select, and then this will be uploaded to this map source. So while that one's uploading, actually here I already have this exact New York tile. So then we can go ahead and zoom in a bit. So we can go to basically any building here, and we can, for instance, try to do a vertical scan of that building. So of course, trees might be a bit of an issue in those cases. But I think let's maybe just go somewhere in here. And of course, it would be ideal if I had some perfect taller building just to show the capabilities. But that might be a bit hard to find very quickly for me. Although actually, no, maybe we will manage. You can hear there might be quite a lot of taller buildings which might need some scanning. So I can just show a bit in general the process of how this works. And at least what I prefer to do is I prefer to compare these types of vertical inspections with Google Earth, because it's very cool, because they have the 3D building layer. And then you can basically see how the flight will look like with respect to the actual 3D building. So let's go quickly back into the map section, and then let's take a look at the base map layer. So here now we have Google Satellite. Let's quickly switch to Bing, because with Bing, sometimes you see those buildings, instead of having them at an angle, you see them exactly vertically. So some cases it could help. But in this case, actually, I think Google is also okay, because at least we have some better detail on the street itself. So now let's go ahead and create a new route in UgCS. Let's use the Mavic 3 Enterprise drone for that. And so then we can go and select the vertical scan tool. And so with the vertical scan tool, so typically you would want to be from the building, let's say about 7 to 10 meters. And in UgCS, we also actually have a measurement tool. So we can do distance measurement, for example, from this point up until here. So you can see it until the middle of the street, it's about 9 meters. And so probably if I maybe drag it about here. So let's say somewhere here where the sidewalk starts. So here it's about 7. So I think that's maybe a good approximation for us. And we can get started. So let's click here on the vertical scan, and then very simple, we can just place 2 initial points. So let's do one here, and this is let's say this, yeah, this building I think goes until about here, and then we place just the second point in here. Then hit enter to complete. If you want, of course, you can add additional points in the vertical scan, so you can actually make it as detailed as you want. But in my case, I don't need all of those extra points. I just want to have this kind of one scan. I'm not sure how tall this building is. This I will double check in Google Earth and then adjust a bit, but most likely it needs to be, the flight needs to be a bit lower. So here in the vertical scan tool, you can actually adjust what should be the minimum and maximum height above the ground. So here I have as the minimum 5 meters, maximum is 50 meters. And in this case, distance to the facade is set as 7 meters. Camera chosen is the wide camera, and the overlap forward and side is set to 80%. There's two different patterns you can use in UgCS for building scans. So we have the vertical and the horizontal pattern. In this case, I think I'll probably use the, actually, it's a bit of a, you can probably use both in this case, since there's as much, it's as tall as long, at least currently looks like. But I think let's go with the vertical pattern. Yeah, then the vertical speed, let's set to 2 meters. Horizontal, we can leave as 5. Um, what also we can set here, so we have the set camera attitude action added, where the tilt is set to 0 degrees. And then the set camera by distance action is also added here. I prefer using set camera by time, but you can use both. And yeah, so that's already our mission. And of course, what's the most interesting thing is let's see how this looks like in relation to the building itself. So what we can do, at least what I usually like to do as a check here, we can go into parameters, then export. And so here we have 3 options. You can either export this as a JSON file, as a KML file, or to DJI Pilot 2. So in this case, let's just export as a KML file. I'll select the altitude. There's 2 options. Either relative to ground under first waypoint, so this will flatten the route down. This I typically use when I just want to have some lines marked out on the map, when I don't want them to be up in the air. If you want the full route to be displayed, you need to choose AMSL. And then the format will be as line string. Let's just click on continue, and then let's export our route. Would you like to overwrite? Yes, please. Okay, so bear with me here. I will need to find where exactly it is. I'll open it up in Google Earth, and then I will switch the screen sharing and share it with you. So I'll stop the screen share now, and then let's switch and see how it looks like in Google Earth. Okay, seems that all right. Seems that my Zoom crashed for some reason, but yeah, sorry about that. I'm back. And then yeah, looks like everything is still working here. And then let's click here on screen share, and then I wanted to share it with you on Google Earth. So now I already opened this file up, and let's zoom in. Oh, and actually, I think I a bit underestimated the height of these buildings. But yeah, so anyways, you can see here, this is the planned route, which we did in GCS, and you can see how it looks like in relation to the building. So actually, it looks like we had to make it a lot taller, so we could make the route not 50 meters maximum height, but we could make it, for instance, 100 or 120 meters even. So let's then maybe we can jump back to GCS. We can adjust it, of course, but we're running a bit out of time. I'll just very quickly, I think, jump back to it. So let's go back here into GCS. So this is, yeah, hope you can all see it. So this is, again, the route we have. So typically, I would probably then just change the maximum height to something like 120 meters. In some cases, also, you'll probably be doing not just one flight when the camera is exactly nadir, well, when the camera is facing at 0 degrees towards the building, but you'll probably be doing also some flights with the camera at 45 degrees, just to capture a bit more detail. But yeah, our time is running, so I think we need to just jump into some other things. And now maybe it's a good point to go into some of the questions you guys have had, and then we can go back into some flight planning and see what else can I show you. So I'll see some questions which were sent to me. So just give me a second here. Oh yeah, there's a question about Terra Following and how to, well, basically how to optimize that. Let's maybe quickly jump back to where we had our corridors planned, because one thing I did not really get to show you or maybe we can see some other. Yeah, let's actually do this one. Let's look at the um, original corridor we had planned. So actually, one cool thing is that in UgCS, you are able to adjust the accuracy at which it follows the terrain. So for example, here, you can see that we are following the terrain at AGL tolerance is set to 3 meters. So this means that for every 3-meter change in elevation, UgCS is adding 1 point in here. If you, for example, don't want it to follow the terrain with this amount, this accuracy, but let's say with less, you can change this to 10 meters, for example. This means that for every 10-meter change in elevation, a waypoint will be inserted. Or vice versa, if you want to have a higher degree of accuracy, you can insert 1 meter here. This means for every 1-meter change, you will have a waypoint in here. Is this good or bad? Actually, I'd say in general, more waypoints is better because this just means the drone will be flying more accurately through the mission, and will be keeping a more consistent distance over the terrain. So it will respond better to any changes in the terrain, as you can see over here. So that's about that. Yeah, about digital elevation model files. Actually, usually based on which country you are, you can get them from different sources. So the one I showed you is ability to get them from USGS, but that's if you are in America. In other countries, there's typically their own. Well, I'm guessing maybe many of you guys probably know from which services you can get the elevation models, but typically each country has its own source where it can grab the elevation files from. Um, then let's see what other questions um, from Ian. We're typically planning missions uploading KML, breaking it into flights for VLOS and through waypoints. Would a different type of route work better? Actually, no, I think if you're planning your flights using KMLs, I think it's quite good because at least there's some form of automation there. So yeah, one thing I can show is that, for instance, if I had some, let's say, KML file according to which I want to plan this route and how it can be displayed on the map, let's maybe just quickly make some adjustments. I'll export it and import it back into GCS just so you can see. Let's wait for this to be calculated. Actually, these patterns, maybe let's remove. So it's just one single corridor line. Okay, and now we can go here into parameters, then export KML and then here, instead of using AMSL like we did for the vertical scan, we can do relative to ground under first waypoint. Then format can be line string. Let's click on continue, and then I'll just save this as, say, route 11. And then we can just click here on hide to hide that route away, and then here in map layers to the objects. Let's insert some. Oh, yeah, I already have it actually here. Let's create some new source. I'm usually a bit lazy with the names here. And then let's click on upload. Let's choose our route over here. And so then you can see actually we have this line here on the map. And so this can typically be used to display, for instance, power lines, or maybe if you have some construction project you need to scan. So all of these things can be displayed on the map like so. Oh yeah, so does GCS have pre-made payload profiles for third-party LiDAR sensors? Here the answer is actually for LiDAR sensors, typically you don't need to have pre-made profiles because you just plan using the field of view angle. We have these pre-made profiles for cameras. So for instance, yeah, like I showed to you for Sony camera and others, so we have these payloads which you can use. So I'll just see then more questions here in the Q&A section. And those ones which I answered, I'll just mark, and then let's go through some others. Yep. One question I have from Valerie is about, yeah, so you do drone inspection on military bases and commercial airports. Use DJI drones. Oh, you do not use DJI drones due to the airspace lock, but the UgCS does not allow to do mission. Oh, I can show this. So actually, UgCS will, unless the drone has its own limitation. So I know DJI drones, like you mentioned correctly, they have their own airspace limitations. So these can be removed if you have the permits. So you can contact DJI and then they can issue you this kind of unlock for that specific zone. But in GCS, we have different no-fly zones of airports in here. So let's maybe just find one airport somewhere. Let's quickly go to somewhere. Well, let's just say Europe. Let's pick usually around all airports. We should have the no-fly zones here displayed. It's just I'm having a hard time finding an airport. Should have stayed there in New York on the map. We can maybe try to go back. So yeah, bear with me, please. But I believe we should be able to see an airport. Yeah, so you can see, for example, here we have an airport no-fly zone, JFK airport. And if you want to remove the no-fly zone, what you can do is you can go here into no-fly zones. Well, here you can just kind of toggle them on and off, the visibility. But in the route settings in UgCS, so let's say if we maybe let's just try to plan some quick flight over here. So if we also just add 2 points like so. Oh, nope, sorry about that. Yep. So we add 2 points like this. Now we should get a warning saying that, yeah, you can't fly routes here. Yeah, because it gets into the airport's no-fly zone. So what you can do if you go here into parameters, and then you can see here, there's a section in the route parameters. So which zones are taken into account. And if you uncheck aerodrome zones, and so then if you need to do those flights near airports, then you can see now this route is calculated. But of course, you always need to have the permits to fly in these areas. So yeah, just make sure that whatever flights you do, that they correspond to the local regulation. But of course, I'm assuming that if you do those flights professionally, then you know all documents there should be in order. But that's how you can unlock them in UgCS. Just one thing to clear up. This is how you can unlock them for drones which do not have the lock inside. Or if you have already, let's say in the case of DJI drones, if you have gotten the permit to fly, you have gotten the unlock from DJI, then in GCS, you just need to make sure that those zones are unchecked, and then you can fly. But for instance, with Ardu or PX4 drones, I'm not sure how it's actually now, but I think they don't really have as many limitations, so you're a bit more free to fly. So let's see then other questions. Oh yeah, is there a way to create a custom return home path in case there are any obstacles between the operator and the flight path? This is a great question. We have been considering adding something like that, but what I suggest doing for now, let's actually maybe go in here. Or let's maybe change our area where we're located a bit. Let's maybe do something a bit more. Let's go to some, again, mountainous area, maybe somewhere over here. So let's create a new route for us just very quickly. Again, let's do our Mavic 3 Enterprise. Let's create some photogrammetry route somewhere up in the hills. So maybe over here, that's where we want to fly. And actually this method, which I'll show you, this can be used for both when you need to move towards the route which you want to fly and when you need to move back. So here you can see we have this photogrammetry mission. It's a double grid, but whatever, that's okay. And but you might be located somewhere quite far away. So let's say if you're maybe, you know, let's say you're somewhere over here and you need to, you know, drove up here with your car and you need to have the drone fly up there. Of course, this would be a BV loss flight, but I'll show you just quickly how you can do this. I would not do this with normal waypoints because if you just, let's say, put a waypoint here and then, you know, you click and add a few more waypoints, How the algorithm works in this case is that by design, it will not add additional waypoints between your waypoints. So in here, what it will do, you can see, so it does, since it sees, okay, so here the flight, it has to cross this mountain, and here the minimum distance is 5 meters. So this means in this case, it will actually fly quite close to the mountain, and you would probably want to avoid that. So then how I would do it in this case, instead of using waypoints, I would be using a corridor. So actually you can go, for example, either in corridor mapping or LiDAR corridor. I'll do LiDAR just because you can set the altitude explicitly. So let's say I want to fly here at 50-meter altitude, maybe even just to be safe, let's do a bit higher. So width is 30 meters, and then let's say let's choose where we have parked our car, let's say over here. So we can then place one point over here, and then next point of the corridor, we can place, for example, somewhere over here already. So basically at the very beginning of where we have our photogrammetry mission, maybe even a bit closer here to this corner. And so this corridor, this is now planned using the Smart AGL feature, which also means that, it will basically follow the terrain very closely. And so now, yeah, what you can see is that actually the drone now will be able to keep a constant distance to the terrain. Of course, in this case, I would still suggest, yeah, maybe getting even more accurate digital elevation model just to be sure. But yeah, that's how you can just with 2 points plan a flight where your drone has to fly somewhere quite far away. Then do the photogrammetry, and then after that, you can actually do the same thing. So, that was actually the corridor after. So now we can plan another corridor after the photogrammetry mission, which will then take the drone back. So again, we can do LiDAR corridor, and then just place one point here, and then another point here at the very end, hit enter, and then, in this flight, the drone will go there and back at a safe altitude with respect to the terrain. So that's how the elevation profile looks like. And yeah, actually here the estimated duration is only 26 minutes. Only thing I would recommend doing here is if you go here into parameters, then there's this action. So what should the drone do in the event of loss of RC? And so since in this case the drone could lose the RC obviously as it goes over the hill, then you can set this to continue. But just make sure, just in case, that in Pilot 2 it's also set to the same value. But this means in general that even if you have this BV loss permit, if you fly this sort of mission, that the drone will be able to fly there, execute the mission, and then already fly back on its own. So yeah, that's how you can do also those types of projects with UgCS without the need to, for instance, hike all the way up here. And another thing actually is you can use the visibility range in many cases when you need to estimate. So how far will you be able to see the drone? So for example, we can, let's say up to 10 meters, a radius that we can then, for instance, set to see the visibility range, at least from this level on the horizontal plane. So how far would you see? So in cases when you need to plan, okay, where is some hill where I might lose the drone's connection, or where I might lose visibility of the drone, also then you can use this tool for that. Okay, then let's go a bit further through the questions. So I think this one also answered. Use Inspired Flight and ArcSky. Yeah, so both Inspired Fly and ArcSky drones, they're supported, of course, in UgCS, but as I understand, you are already using it. So what's the relationship between GCS and Autopilot? I'm not sure if you mean this as a relation between our company and Autopilot organization, or in terms of support, but we do support all Autopilot drones. And so this includes normal multirotors, VTOLs, and even fixed wing. So even Autopilot fixed wing drones can be used with UgCS. So yeah, any pilots who use either Autopilot or PX4 based drones, they can switch from using Mission Planner and Q ground control to using GCS for when they need to. There are a few questions actually regarding the iOS version. I think also makes sense for me to cover it. So why don't we have an iOS version for our app? And actually, so we used to have an iOS version, but we had to discontinue it, unfortunately. And this was because DJI also, they had an iOS SDK, which developers could use. But DJI also didn't really focus that much on the iOS. Priority was Android because, as you see now, Android is also actually integrated in DJI smart controllers. And yeah, that's why iOS has, we also had to discontinue it just because of lack of support from the DJI team side. Yeah, if another question from Alessandra. So if you have a DJI Mavic 3 Enterprise, what's the connecting app to use? So with M3 Enterprise, you need to use DJI Pilot 2. So so basically with M300, M350, Mavic 3 Enterprise, and M30. So with these drones, you can use Pilot 2 app to connect directly to GCS, which means you will see the drone in here, and also you'll be able to see all of the routes from GCS in your Pilot 2 in the cloud routes section. And if you want, you can also, of course, save them into local storage. By the way, also one thing I just want to show you guys here is that for these types of projects, just before I forget, is in many cases you will probably be flying in areas where you'll have limited or no internet connectivity. And so actually what UgCS does in those cases is that you can download the map and elevation for offline use. So if you right click anywhere on the map, you can select offline map and then just click and select the map region you want to cache for offline use. Hit enter, enter some name. Let's just call this region 1. Click on create. And so now you'll see that this region is being cached for offline use. So this is one of the advantages of having GCS installed locally on your computer. So I know some flight planners for desktop, they are browser based. We are not. So GCS you install locally, and this also means you can catch maps, catch elevation, and you're not really tied to having to rely on internet connection. If you're in the field and you need to connect your drone to GCS, then what you can do is you can simply use any kind of network router or mobile phones hotspot. So again, doesn't mean it needs to have internet, just needs to be able to connect both devices. But in fact, you can also just use USB tethering between the remote controller and the computer to be able to connect when you need to. Or just cache the routes within the DJI mobile controller and then fly without even having to open up your computer. So let's go then a bit further through the questions. Let's see what else can I answer. Yeah, from Paul, that last time you were using GCS. Oh, yeah, that when you uploaded the route to the drone, that the route was locking. And actually, this is kind of a bit by design. So whenever you have a route and then you upload it to the drone, after the upload, the route will be locked. And so you won't be able to make any changes to it. This is just to prevent you from changing it accidentally. And also, since one of the things we are planning on adding soon is a flight timer, and also for that, it will be necessary for us to have this sort of information of how long the route is to be able to correctly estimate it. But anyways, if you need to unlock the route for editing, you can always do that. So you can, let's say you now have this, I think this, yeah. So route number 4, this is now locked. So you can see I now can't change any settings, can't move it around. There's 2 things you can do in these cases. So number 1, obviously you can just unlock the route. But if you have the drone flying the route already and you want to make some changes, what I would recommend is that you can, even while it's locked, you can still create a duplicate of the route. And then to that, you can make any changes which you need to. So 2 different ways, 2 different approaches, which you can do, either duplicate the route or just unlock it and use it. Yeah, so there's another question. So what is the best method of flight planning or camera triggering using time or distance? I would say that from my experience, when you're flying some horizontal mission, then actually distance tends to work best. So then simply, let's maybe actually create some very quick route for that I can show you. So let's say some quick photogrammetry in here. And here we can set we have the set camera by distance. If we then go ahead and click here on this green checkbox, so then here you can see actually different route parameters, such as total area, footprint, number of waypoints, passes, as well as these parameters for camera triggering by distance. So you can see how many shots will be taken approximately and how often the images will be taken. So if you want to change this, so in this case, this will be every 15.82 meters. And if you, for instance, had the set camera by time instead, then you will see how every, like, basically the number of seconds. So in this case, every 3 seconds, an image will be taken. So yeah, typically in most cases, actually, I prefer using set camera by time, but I'd say that actually in horizontal missions, set camera by distance might work best. But when you use vertical scan or vertical flight planning tool in UgCS, then I would recommend using set camera by time because I think that works a bit best for vertical missions. That works a bit better for vertical missions. So that also answered. Yeah, smart oblique. This I showed. Um, that also I think I answered. Yeah, about importing your own DEM. Also, this I covered. Oh, interesting, actually, suggestion I see about the figure eight for LiDAR flights, having it automatically added in at the beginning of every LiDAR flight. Uh, Interesting suggestion, actually, we might consider it. Um, Yeah, again, question about how accurate is the underlying terrain data. So here, like I said, we're using SRTM1 arcsecond data, but so this should be enough for most missions. But if you fly in areas with very, very steep elevation changes, then it can sometimes be better to get more accurate elevation data from other sources. So yeah, like I said, typically each country has their own source where you can get publicly available data sets. So, okay, let's see. Is there another way I can choose the distance between my profiles based on fixed intervals in meters? Oh yeah, if you want, for instance, to have um at least do you mean, so it's from Alexandra. Do you want do you mean having set camera by distance set to a certain um distance or something else? Because if you mean set camera by distance, then you can see we have here it's set to auto, but you can also actually enter your own values. So if you, let's say, want to take a picture every 1 meter, you can do that, but keep in mind the flight speed because you might receive an error here. Yeah, that, let's say, the triggering interval, if you fly at 5 meters per second and want to take an image every 1 second, this means that every 1 meter, this means that triggering interval will be 0.2 seconds. But Mavic 3 Enterprise minimum interval is 0.7 seconds, at least according to the data sheet. So you might just need to fly a bit slower. So let's say something like 2 meters per second, for example, which already brings you a bit closer to that. But in any case, yeah, we have this auto setting, but you can also set it to trigger every certain number of meters, however you want it to be done. So let's see. Oh yeah, interesting. Actually, interesting question. Is it possible to record a live flight with related camera inclination and then translate? So basically, then be able to repeat that flight. So all the flights that you do with UgCS, these are recorded in our telemetry player. So if you go here into the main menu and then telemetry player, I'm afraid here I will not have actually any telemetry recorded because this is a fresh installation. But so you will have this some telemetry file in here. And then when you have that, actually you will be able to export telemetry. And if I'm not mistaken, one of the options, you can either export it to CSV file, but I believe also one option was KML. And this means that you can actually do a flight, and then that KML file you are able to import back into UgCS as a route. And well, if later, if you have some time, I can also show this to you. But yeah, idea is simple. You do a flight manually while drone is connected to UgCS. While it's connected, the telemetry data will be recorded. Then you find it in here, click on export, export to KML. And then back in the mission editor screen, you can create a new route from file, and then you can choose that. Only difference is that it will not account for the camera changes. So those you might need to adjust manually. But it's actually an interesting suggestion to also save it and have some way. I know maybe for filming some cinema, it could be very useful. So yeah, another question from Grayson, can UgCS import custom DEMs? So yeah, in case you missed it, answer is yes. So in here, map layers elevation, this is where you can import custom digital elevation models, surface models. As long as you have it in a GeoTIFF file, then you will be able to import it. So yeah, about oblique imagery here also, I believe I showed this. So yeah, basically idea is that you do a double grid photogrammetry, and in the photogrammetry, you set the camera to, for example, 45 degrees. Like I mentioned, alternative is doing two separate flights, one with 60 and one with 30%, not sorry, not percent, but degrees, 60 and 30 degrees, and this will allow you to get even more detailed model. But I suggest, yeah, if in case you maybe it's something new you want to do, just start out with 90 and 45, and then go from there. Okay, let's see what else I can cover. Oh yeah, interesting question also from Alexandra. With DJI Pilot, there is a limit of 12 meters in terms of minimum altitude for a survey. Is it possible to GCS to do surveys at a lower height than that? Answer is yes. With well, firstly, we have a system which is called UgCS Sky Hub, which allows through terrain following for drones, but this is for larger drones. So M300, M350, you can go on our site, search Sky Hub, and then also you are able to order it, and it works by having a radar altimeter on board the drone, allowing it to follow the terrain. But if you just want to, let's say, have some very flat area without a lot of elevation changes, and you want to be able to do a flight there, then also you can do it even without having a separate altimeter on the drone. So let's go in here. I'll just very, very quickly show how this can be done. So let's go ahead and create a new route. Let's do Mavic 3 Enterprise, and let's just do an area scan route. So let's set the flight altitude here to 5 meters. And then let's maybe I'll just make it very, very short, nice and clean, like so. But this is 5 meters, but actually, even if you want to go lower than 5 meters, and actually here you can see that how it was calculated at some points, the altitude will be lower than 5. And that's why you get this error. But what you can do, if you go here into the main menu and then drone profiles, then we go to Mavic 3 Enterprise, edit, and then here we should have a setting which is the minimum, yeah, safe height above terrain. And if you want, you can change this to, for example, 2 meters. And so this will mean that if you want to, let's say, plan a survey mission at, let's say, 3-meter altitude, then you will be able to do that. So let's go here, again to our mission. And so now you can see we have this mission already at 5 meters. You can see the elevation profile. Here also you can see the minimum and maximum altitude above the ground. And if you want to do even lower, then also you can, for instance, select, let's say, 3-meter altitude here. Where is this useful? Actually, I know there's a lot of users who, for instance, they use UgCS for agriculture. And yeah, in agriculture, sometimes you need to have those very highly detailed images of the crops, which people, for instance, then can input into software which automatically processes these images and then can find various defects, diseases within the plants. So that's just one of the applications where these low altitude surveys are done. But also similarly, we have users using magnetometers with GCS, with both DJI and non-DJI drones. So also one of the applications where these lower altitude flights are required. So yeah, great question. Thank you for that. So that's that. Let's see. There's a lot of questions today. I think we need to do these kind of sessions more often. So let's see. What else can I answer? Yeah, well, it's an interesting question. What's the best way to divide up a large multiple battery photogrammetric mission? So we can take actually the same mission which we have here. Let's set the flight speed to, oh, sorry, flight height. Let's set a bit higher to, for example, let's do 30 meters. And you can also increase the size. Well, actually, how I would cover very large areas with drones. So, for example, firstly, I would mark out the borders of the area. And so this you can do either by, let's say, planning some very simple mission in UgCS or by importing the same KML file. For example, if I use the perimeter tool in a separate route, what I can do is I can mark out the exact area like so. I can then go ahead and once it's calculated, I can go ahead and export it into KML. Oh, here I again need to change the fence radius. But yeah, the general idea is like this. I usually mark out very like the borders of the area. And then if you have some photogrammetry mission, you can actually just go ahead and duplicate that mission and then move it around. But also what you can do is, of course, if you need to do a flight where you change the battery and do multiple battery sets, then in UgCS, there's a few options how you can do that. Let's just maybe add the emulator drone in here. So basic idea is that when you upload the route, here I'm getting now this error, but when you upload the route, there will be options where you can select how should the route be flown. So when you start it initially, you just select start the route from the very beginning. When you resume it after battery change, if you use UgCS for DJI app, for example, or use some autopilot or PX4 drone, then you can select either start route from waypoint number and then input the number of waypoint, let's say waypoint number 82, for example. And so then you can start the route from there. And also for some DJI drones, you'll have a third option, continue. So in that case, you can just, continue the route flying from exactly where it left off. But yeah, and then actually once you're here, you can just go ahead and arm and then auto mode and launch the drone on the mission. So that's that. Sorry, I'm just running a bit quickly through questions. I want to answer as many of them as I can. Is it possible to get Google Earth as a map layer in? So from Google, we have Google Satellite and then also Google hybrid map layers here. But if you want to exactly get Google Earth, the same map which is in Google Earth it might not be that easy. But if any custom map source actually can be added. So if you click here on add, so by default, which is what you saw here before, was just GeoServer option. You can also actually choose some external map source and just provide a source here. So this means that actually any map which you want to integrate with UgCS, this probably can be integrated and can be put in here. So just one note about that. Yeah, another question. When I stop flight route mid-flight, weapon number resets. Oh yeah, when you if you're using GCS for DJI, I'm assuming, then yeah, that's correct because on the remote controller, when you upload the route, let's say like I did here, I uploaded the route starting from waypoint number 82, and if I was using, let's say, DJI M300 drone with our mobile app, so how it would work is that actually only this part of the route is sent to it, so it would be shown as waypoint number 1. So yeah, that's true. I know it can get a bit confusing if you do a lot of battery changes. My best suggestion here would be just to follow the route in UgCS, and yeah, from here you can understand. So where is the drone exactly in the route? So for those more complicated missions, it really does help to have UgCS with you in the field. Another interesting question, yeah, is it possible to take images at multiple different angles at the same waypoint? For doing this, actually, what you can do, I'll just again show very quickly. Sorry, I'm kind of running through. I want to be able to answer as many of you as I can. So let's say we have just very simple mission, these 3 waypoints. Now in the middle waypoint, we can add, for instance, set camera mode and shot. So, and before that, we can add, for instance, let's do change camera. I think for the emulator, we might not have the camera attitude. Yeah, that's what I need to change the drone's profile here. So let's just select some normal drone. Let's do M3E. And so then, yeah, in this case, we have still the camera shot. We can also then set the camera tilt. So let's say 0 degrees. We have this action as the first one, then camera shot. And then again, we can have, for instance, change camera tilt, let's say 45 degrees. And then again, we can add the set camera mode shot actions. Now we have 2 tilt actions and 2 camera shot actions in a single um, waypoint. So yeah, hope I answered that. Let's see what else. I'm just kind of a bit skipping through. I'll take some of the latest questions. Let's see what I can cover. Yeah, about camera sensor size and pixel size. If you need our help with this, if you're not sure what's the sensor size for your camera, you can also always just get in touch with us at support@ugcs.com and we can help you with that. There's also various online calculators to how you can get that, but also you can always contact the camera's manufacturer and ask, so what are those, what settings should you use? Okay, let's see what else. Oh yeah. I think so. This question is from Don, and so I understand you had some issue when you were flying up a hill, and then GCS would not calculate the route. I'll just very quickly explain why this most likely could have happened. This might not be the best place where to do that, but I'm assuming you were very likely flying with smart AGL. And let's just maybe do some very simple route. Let's do LiDAR corridor and then just 1 point, second point. So Smart AGL works in the following way, that in order to achieve this, let's say you have it set to, for instance, 50 meters. And in order to achieve these 50 meters, then in GCS, it might have to set the exact waypoint higher than that just to achieve the distance to the closest surface. So there's 2 approaches. Either you use normal AGL and then GCS will set the flight height exactly below the drone at 50 meters. Or if you're flying up a hill like this, if you get the error saying that the route cannot be calculated, this is most likely because Smart AGL, it had to, in order to achieve this distance to the vertical cliff wall, it had to make the drone fly higher than, by default, you would have 120 meters here. So what I would suggest is, yeah, either try using normal AGL and seeing what that will most likely fix the initial issue, or with Smart AGL, you can just change the maximum altitude of the drone. If you need some help, you can always just email us at support@UGCS and we will get you sorted and help you with your mission. Yeah, let's go here, but actually we're running a bit short on time. So I will not be able to answer all of your questions now, but to any other questions you might have, please either email us at support@ugcs.com, or also we have a Facebook group with GCS users in there. So I know many of you probably already know this, you might be there, but in case you're a new pilot with UGCS and you might not know, then if you search on Facebook UGCS user group, then you will be able to find it. So it's just a group where there's other UGCS pilots. You can ask different questions about flight planning, share your ideas, feature suggestions, and so on. So yeah, I highly recommend you visit the group and see what's there, interact with other pilots, and so on. I'd love to answer all of your questions, but now we're already 1 hour, 40 minutes in, and we had this plan for about 1 hour. So I think I will have to probably end this here, most likely. But sorry, I didn't get to answer all of your questions. Please put them in the Facebook group or just send them to us at support@ugcs.com, and also we will be able to help you. The recording of this training, it will be available on our YouTube, so it will be sent to you. Yeah, so I hope it was a good session for you. Hope you learned something valuable. And if you want to have more sessions like this, then, comment on any posts we have, interact with us, let us know you want more sessions like this, and then we can do that. Because looking at the amount of interest I'm seeing today, maybe we really need to do this every month, for example. So yeah, thank everybody for coming. for listening. And yeah, then see you in the next one. Bye.